This meeting is being recorded.
All right, y'all. Someone needs to maybe mute.
Hey, someone's got a hot mic. It's hard to hear. I'm sorry, but someone else has a hot mic besides Shi-Chin.
I think I got it. All right, y'all. So, like I said, this is 2.1, and we'll be looking at graphs of equations. All right, so I got a chat. Let's see what y'all are asking. Are we on section 2.1? Yes, sir. So 2.1 deals with graphs of equations, and we're going to look at, some of y'all should be familiar with graphing straight lines if you had earlier math, but we're going to do curvy lines also, V-shaped graphs, and all kinds of fun stuff. So let me start off with the first type of graph. Y equals mx plus b, or it could be in the form of ax plus by equals c. So let me ask y'all if y'all remember this. These x's I got here that are my variables, if they don't have exponents by them, what would the exponent be?
It's 1, right?
1.
I think you said a 1, perfect. So my x's would have a 1. Anytime you got a variable like this x and the exponent is a 1, these are going to be linear graphs. And in MATLAB, you'll use the line tool that has the 2 points on it. So x's to the first power are linear. So I'm going to do a few examples of those, and then we'll go some 2's up there, okay? So y'all watch this. Y equals, oh, how about a 5x plus 2? So we'll have our little graph over here. I don't know how far it's going to go yet, so I won't number it yet. But x is my horizontal, y-axis is my vertical. So let me see what kind of numbers, and then we'll figure out what we're doing to this. So in here, the main way you want to graph is what I call table method. So you're going to make up an x and y table. And each number I get for the y, when I put my x values in, each one of those rows is going to give us an ordered pair that we can graph. So this one wouldn't be too bad. I'd probably use some really small numbers on this one. We can pick any 2 numbers we want for the x. So how about say a 0 and a 1? If you wanted another small number, maybe a -1. Because when you're doing them by hand, you don't want these graphs going real big, okay? So now what you do with each x is put it into this equation and see what the y values are. So I want to do that 3 times. I'm going to put a 0 in for the x first. I'm going to put a 1 in for the x second. And then I'll put a -1 in for the x on the third one. So put these 3 x's in the equation, and let's see what we get for those y values. So y'all, the first one, 5 times 0 is 0. 0 plus that 2 I'm bringing down. That's going to give me 2 for that y value. All right, I put a 1 in next. 5 times 1 is 5. Bring down your plus 2. 5 plus 2 gives me 7. Now we use that -1. So I put my -1 in here. 5 times -1 is -5. Plus my 2. -5 plus 2 gives me a -3. All right, so notice my y, the biggest y value I have on here is a 7. So now I know I can make my graph out about 7. So there's 5, 6, 7. 5, 6, 7. I'm negative going down the y-axis, and I'm negative going left on the x-axis. So y'all remember, here's your points. This is like ordered pair 0, 2. This is an ordered pair 1, 7. And this is an ordered pair -1, -3. Your X's are always first and then that Y value. So now y'all, in MathLab, even if they make you do 3 points, you only need to graph 2 of these in MathLab, okay? So 0, 2, you don't go left or right on the X-axis, you stay at 0 and then go up 2 for the Y. 1, 7, you go right on the X1 and then up 7. So right 1 and up 7. So at that point, I could draw my line, but this third point will check my accuracy. If it's in the line with the other 2, then I know I did my graph good. So I would go -1, -3. And if you notice, y'all, if you draw the line, if my spelling was nice, it'd be a nice, perfect straight line through there. So bringing back memories, hopefully. So y'all, question on that? Y'all good? All right, so let's try this one and see what we're going to do. 8y plus 4x equals 4. So this one, before I get me a table for this one, I always want to solve these for the y. Now, the little bit of the support homework for 2.1, it'll actually have you solve some of these for the y to get you practice at it. Now, I'm solving this for the y. I want it to look like this. Y equals something plus something, okay? So the first thing, tell me, how would y'all get this 8y by itself on that left side?
Subtract the 4x.
Subtract the 4x, perfect. So to move it from side to side, use subtractor, add. And good job, since that 4x was positive, we had to subtract it. So y'all watch this, the 8y comes down. 4x is canceled on the left side. So let me ask you this. Can you add that 4 and that -4x?
Negative.
Exactly. They're not like terms, so you cannot add them. So I usually just put the x first and then my 4 after that. But it wouldn't be wrong if you put 4 minus 4x if they weren't specifically asking for that order. Just make sure variables can't add to numbers. Now, here's a question. Y'all got 8y on the left side. What could y'all do to maybe turn the 8y into a 1y?
Divide it all by 8.
Divide it all by 8. So y'all did the fun part. If they don't divide equally, we're going to have to reduce these fractions. So the 8 divided by 8 did reduce to a 1. So you got my 1y all by itself. So now y'all would need to reduce that -4x.
Greatest common factor of 4.
Say again?
Greatest common factor of 4.
Yeah. So divide both in by 4. That gives me what, a -1 over 2 with my x. Good job. It looks like we got the same fraction, right? 4/8 again. Divide both in by 4. Get a 1/2. Now, I will say on this one, it's tricky when you got these fractions. So I'll just go out about 3 big numbers. So that'll be going to 3. Because what MathLab will do, since we got a bottom denominator of 2, MathLab would split these into halves on these, okay? And they would put halves in between everything. So it would be 1/2 1, 1 1/2 2, 2 1/2 3, so on, okay? So y'all, what I need, I want some small numbers. I'm probably going to use a 0 and a 1 again. So that means I'm going to have, for my two equations, I'll have y equals -1/2 times 0 plus 1/2. We all look at that. 0 times -1/2 is 0. And your 0 plus 1/2 is 1/2. So my first point would be 0, 1/2. Now, if I put a 1 in for that x right here, I'll have y equals -1/2 times 1 plus 1/2. Well, -1/2 times 1 is -1/2. Bring down your plus 1/2. Oh, no, that's not too bad. -1/2 plus a positive 1/2. That's a big 0, right?
Mhm.
So at 1, we got a 0. So what you would do, since they broke this into halves, 0, 1/2 would start at 0 and just go up 1/2 unit in between 0 and 1 there. And then 1, 0, I would go from, remember, that's a half. That would be my 1 right there. Okay. So MATLAB is going to break that down so that you can have them halves in that thing. And then you'll come in and it'll draw your line for you. All right, so remember, when the variable has an exponent of 1, this thing will be linear. So let me change that exponent up to a 2 now. So if I had something like y equals how about y equals a to the x squared? Or even y equals x squared plus some number b. But notice, the exponents on these variables are now 2. When the exponent is a 2, this is what we call quadratic, or the squaring function. This has a special graph. When the exponents are 2, your graph is going to look like a U. Y'all remember what we call that?
Parabola?
Parabola. Good job. And you'll notice these parabolas, the negative numbers have the same y values as the positive numbers that you're squaring. Okay? Think about this. What's a positive 1 squared? Positive 1, right? What's a negative 1 if you square it?
1.
It's going to be a positive 1 also. So anytime you square a variable, you got to square that sign with it so that it becomes positive. Anything we square has to be positive, okay? So let's do an example of these. Let's try y equals -2 x squared. Now, when you're doing these x squared graphs, there's 3 numbers you're going to use every time. You're going to use a -1, 0, +1. And you can use those no matter what whichever form it looks like, as long as it's x squared. Let's go with these 3 numbers. So we'll be figuring out y equals -2 times -1 squared. We'll figure out y equals -2 times 0 squared. And then we'll have y equals -2 times that 1 squared. Now, y'all, when you do negative numbers on your calculator with exponents, put those negative numbers in parentheses on that calculator, or it will give you the wrong sign for your answer, okay? All right, so here's the thing about hit people. PEMDAS means start with parentheses first inside of them. Exponents is the E. M is multiply or divide left to right. The A and the S represent add or subtract, left to right for order of operations. So parentheses, I can't do nothing in these parentheses. They're just numbers. So I'm going to do the exponent first. So that exponent 2 affects those parentheses right there. So my question, bring down that -2. It's going to multiply by whatever -1 squared is. Remember, -1 times -1, 2 negatives make that a positive.
Positive.
And guess what? Now your exponent's gone. Now you can multiply because that's all we got left. So that's what, -2 and 1, -2. So my first point, -1, -2. Now look here. Exponent first. So bring down that -2. Well, y'all, that's going to multiply by 0 squared. And 0 squared is a big 0. And -2 times 0, 0 on that one. So my second point will be 0, 0, and that's the center of the graph right there. Now watch what I do. I'm going to put the 1 in. So I got to do the exponent first. So I'm going to bring down that -2. All right, 1 squared, 1 times 1 gives me a 1. And then look at there, -2 times 1 is -2. So what do you notice about the -1 and the +1? They got yeah, they got the same y values. -2 would have the same y value as 2 and so on this graph, okay? All right, so let's draw us a little graph here. Now, MATLAB, you would have to use 3 points like the tool has on it. All right, so -1, -2, go left to -1, down -2. You'll have your 0, 0, which is right in what we call the origin of that graph. And then 1, -2 goes to the right 1, down 2. So when you plot that third point, MATLAB will sort of draw that little curvy upside down parabola for you, okay? So this one was upside down because of that negative in the front. That negative sort of flips them over. And we learn more about that sort of later on in life. All right, y'all, let me put one in real quick. Let me find it here. All right, question on that, y'all. Remember, x squared graphs, use those 3 points, okay? All right, the next one I'll look at, y equals, I got a bar here, and how about x plus a in the bar? So can anybody tell me what these little bars represent?
Isn't that absolute value?
Absolute value, good job. Now, if you're doing order of operations, absolute value brackets have the same priority as we do with parentheses, okay? Now, these absolute value graphs are going to make a sharp V. And on this one, MATLAB only requires you to have 2 points, but you got to have that point first. So that must be the first point to plot. So you plot that point and then 1 point on either side, it draws the V. Now, I'll tell you how I get that point when I got my problem going, okay? So let's bring down the example. I'm going to do y equals absolute value of x minus 2. So y'all come over here and start your x and y table. So the first point I pick, first point needs to make the inside equals 0. So see, what number could I put in for that X that would make that equal 0 in there? That's the first point I want for my X.
2.
So that's going to be a 2. And that'll always get that point for this section, okay? Now, any other point I can put? How about a 3? That's right next to it. So what we'll be figuring out is y equals absolute value of 2 minus 2 to get my first point. Then we'll do y equals absolute value of 3 minus 2 to get the second point. And y'all know what's nice about absolute value? Whatever's inside that absolute value brackets, no matter what sign it is, it comes out as what?
Positive.
Positive every time. Good job. All right, so let me see what these numbers are going to do. We got a 2 in here. Work the inside the parentheses. 2 minus 2 is 0. So now I've done inside, I can do the absolute value, and the absolute value of 0 is 0, right? And then the second one, absolute value, we do the 3 minus 2 first, which is 1. And then the absolute value of that 1 is a 1. All right, so that's not very big. So we'll come out 3, 4, 5. 1, 2, 3, 4, 5. I don't really need no negative ones on this. All right, so y'all math lab, you're going to click that V-shaped tool, plot your point 2, 0. So go right 2 and stay at 0. Then this one was 3, 1, so I'm going to go right to 3 and up 1. When you put that second point, MathLab is going to come in and make that thing look like a V. Okay. Oh, y'all, let me check my participants real quick. I got one thing they're in a waiting room. Let me go look. I'll share this right back in a second. Oh, I'm not seeing no one waiting. All right, oh well. All right, y'all. So remember, parabolas, the x squared graphs, 3 points right here. Absolute value, 2 points, but the first point has to make that equal 0 inside those bars. All right, so one more graph out of 2.1, and then I'll move y'all into 2.2. So this one will look like y equals x to the third plus some number minus some number. When you got an exponent 3, these are cubic. And the tool for it will look like a squiggly line in MathLab. And y'all, that thing's going to have 4 points on it. So we find 4 points for this one to plot it, and we're good to go. So let me tell you the thing about X3 graphs. You don't want very big numbers on these X3 graphs, okay? I'll probably keep my numbers small when I do this. So my example is going to be y equals x to the third minus 2. Y'all, you know what that exponent 3 can do, right? It can turn small numbers big really quick. Think about this. What is 3 to the third power equal?
27.
27. Y'all, I'm not drawing my graph out 27 lines, okay? So numbers I would do on these cubes would be 0s, 1s, and 2s. 0, -1, 1, and 2 is all I'm using on this one. Like you said, 3 would put 27 there. 4 to the third is 64. So they get quite big, okay? All right, so let's see what kind of y values we get, and then we'll fill that thing out. So I'm going to have to do y equals 0 to the third minus 2. Y equals 1 to the third minus 2. I'll have y equals -1 to the third minus 2. And then y equals 2 to the third minus 2. So I put all 4 of my x's in there to get my equations. And you got to love 0. Once again, 0 to the third is 0. Bring down that minus 2. 0 minus 2 is a -2. So 1 to the third power is 1 times 1 times 1. That's going to give me 1 minus 2. So y'all, what would y'all put for 1 minus 2?
-1.
-1. Good job. Got to keep y'all square on them signs, okay? Now look here. That's a -1 to the third. So what would you get with a -1 times a -1 times a -1?
Negative.
Yep, so that's going to be -1, and then -1 minus 2 gives us -3. Good job. All right, then we got 2 to the third. 2 times 2 times 2 gives us 8, and then 8 minus 2 gives us 6. So we kept it sort of small, but those things, woo, they can get big within cubes. So I'll just go out about 6 on this number line here. So like I said, grab the 4-point cubic tool, the curvy one with the 4 dots on it, and plot our 4 points. So we got 0, -2 will be on the y-axis. 1, -1 will be right 1, down 1. -1, -3 will be left 1, down 3. And now finally I got 2, 6. So right 2, up 6. What happens when you put the last point? Math Lab will come up here, sort of draws the line through your points and finishes up for you. So y'all, question out of those graphs out of 2.1?
No.
All right, so what we'll do next, 2.2. So 2.2 is more about domain and range type stuff.
So I do have a question. I'm sorry, on 2.1.
Uh-huh.
On the quadratic or squaring formula, you said that the homework will give us it'll complete it. So we'll have 3 points or the 2 points?
It'll have 3 points on the quadratic.
No, not that one. I'm sorry. It was the V-shaped one. So the V-shaped one.
Absolute value. Although it's got these 2 sides like the quadratic, it only makes you do 2 points.
But the computer will make it into a complete V?
Yeah, once you plot that second point, it slaps that other side on there for you.
Okay, thank you.
Yeah. All righty, so this section, 2.2, functions and graphs. So we teach you a little bit about functions and domain and range, and a little bit what we call function values. All right, so let me see. All right, so to be a function is what we call a correspondence in which each member of the domain now remember, domain is like your X's, okay? But each member of the domain corresponds to one and only one member of the range. So remember, the range is what your Y's. That means if you look at an X value and you start looking at its Y value, it can only have one Y value. Okay. Just like when you get paid. If you work 5 hours, there's only one pay you want. You don't want to have choices on pay, okay? So remember, it's 1 to 1. My X's can only go to one Y value. So let me show you a few little examples doing that kind of stuff. I'm going to make a little table with a domain on the left side and a range on the right side. My domain, I'm going to use an 18, 21, 14. My range, I'll do a 17, 25. So the 18 goes to the 17. The 21 goes to the 25. This 14 goes 14 goes to the 17. So my question, is this a function? Does each of my X's in my domain correspond to one and only one member of that range? Yes or no?
No.
So I got this is not a function. Is that y'all's vote?
Yes.
All right, so let's follow this. This is my first X is 18, right? Y'all with?
Yes.
Mm-hmm.
How many Y values does that 18 point to?
1.
1.
Okay, so it only points to one value. Your next is a 21 for your next X. How many Y values does that 21 point to?
1.
1.
Uh-huh. Your next X is a 14. How many Y values does that X point to?
1.
So y'all gonna change this to a?
Yes.
Yes. Don't focus on the Y values. You got to focus on the X's, okay? These X's can share a Y value, but these X's cannot have a choice between the Y's, okay?
So what was the question that you asked for us is
I just asked y'all, is this a function?
right? And then you said how many, you said,
How many Y values did each of these X's point to?
yes, okay.
If it's only one value, then you got to call that a function, okay? So let's try another one. Domain, range. So on this one, I'll have, say, -3, -4, 6. My range, I'm going to make that a 5, 6, 7, 8. So my 3, it pointed straight across to that 5. My 4 is pointing to the 6. It's going to point to the 7. My 6 is going to point to the 8. So here's the question. Is this a function?
No.
Good job, because this time I do have someone violating what we said up here, right? So the -3 was good. Even a 6 was good. But unfortunately, that -4 points to 2 different Y values. So because of that happening, this is definitely not a function. But y'all, let's try one more and see if I can't trick you up. My domain and my range. So my domain, I'm going to have 5, 10, 15. My range over here, I'm going to have a 20. And y'all, all three of these are going to point at that 20. So here's my question. Is this a function?
Yes.
Yes.
Oh, good job. Good job, because every X is only going to one Y value. That's like when y'all work for, say, salary pay in your hours. It don't really matter on the hours, you still get the same pay. Well, my hours could be different, but my pay might be the same. So that's an example of a single range being a function with different Y, X values, okay? All right, y'all, so the next thing we're looking at, a little more algebra here. This is called function notation. So we're talking about the f of x stuff. We call this f of x. All this is symbolism. F of x is symbolism to let us know we have a function. Now, if a number is given in place of the variable x, so if a number is given in place of the x, then we substitute that number into the equation. Actually, we substitute that number, let's say this, into the function. And so, y'all, I'm going to give y'all some examples doing this. And this is the big thing we do in college algebra, okay? So you want to get good at being able to do these substitutions here. So this first example says, given h of x equals x plus 13, find the following. So they want us to find what does h of 0 equal, h of -1, h of -3, h of 7, and h of a c plus 15. So, y'all, here's the function. The function is this x plus 13. That's the only thing we're worried about putting the numbers into. H of x just lets me know I got some kind of function. And remember, if we had a number in place of the x, that's what number goes into this x plus 13. So h of 0, they're wanting me to put that 0 in for that x. So this would make this a 0 plus 13. So y'all add that and we're done. 0 plus 13 gives me a 13. So h of 0 is 13 because when I put a 0 in for the x, that's what I got. So y'all watch this. H of -1. Take our function and put a -1 in for that x. We get -1 plus 13. All right, y'all, so let's think. What's -1 plus 13? That's what? Positive
12.
H of -3. I'm going to put a -3 in for the x. I got -3 plus 13. So let's see what's that.
10.
Yep. So how about this? What y'all getting for H of 7? That's gonna be what, a 7 plus 13. So that's what? 20. Then look at this. They come with the curveball. They got a C plus 15 here. So guess what I'm going to replace that X with?
C plus 15.
B plus 15. And then at the end, I still got a plus 13. So let's see how sharp y'all are today. Can I go further with that one?
Yeah, it's you can reduce it down or combine it to a C plus 28.
Right there, you got like terms. Good job. 15 plus 13 will add and give me a C plus 28. The y'all are not too bad. It's just, you know, keeping up with this just being symbolism and letting me know that they're giving me the numbers to put in for those X's on each of those, okay? So let's try this one. This one actually has an f of x. So given f of x equals x to the third, they want us to find f of 0, f of -1, f of 4, f of 8. Oh, man, if I got a calculator on some of these, y'all. F of -2. And then finally, f of a -3a. All right, so my function is this x to the third. All I'm going to do is put each of these numbers in for the x, multiply them 3 times and be done. So we're going to put a 0 in first. All right, y'all, 0 times 0 times 0. Big 0. -1 to the third. You're going to put that -1 in parentheses to the third.
-1.
-1, good job. Oh, here's a good one. I got a 4. That's getting bigger. Well, how about that, y'all? 4 times 4 times 4.
64.
Well, this is even bigger. We got an 8 sitting here. 8 to the third power. All right, y'all, how about that? 8 times 8 times 8.
And 512.
You say 512, didn't you?
Mm-hmm.
Okay. That's why I don't pick 8s on that cubic graph, okay? I'm not drawing my graph out to no 500, right? All right, y'all, -2 to the third. That'd be what? -2. -2 is 4. 4 times -2 makes that a -8. So how about this one? What would y'all do for this? -3a to the third power. Any guesses on that one?
That'd be 27a cubed.
Oh, you just said, what you just say?
27a to the third power.
Woo,
20
there's only one thing you're missing.
It's a
oh,
negative.
negative 27.
Yeah.
Negative, there you go. Because remember, an odd number of negatives, we'll keep them negative. So -27a to the third. Good job, because remember, the a don't have an exponent, it's like a 1. And when you got exponents, raise the exponent, you multiply them. That's how they got the 3, okay? But that makes sense, right? A times A times A. Y'all, questions on that?
Just that last one you just did. Just trying to figure that out.
This one? So
Mhm.
2 ways you could have done this. You could have took this and wrote it 3 times. So basically multiply all the 3's together. So -3 times -3 times -3.
Okay.
You got that -27.
Mm-hmm.
And if you write the A's out like this, remember they all got exponent of 1 on them.
Mm-hmm.
And when you multiply variables, remember you just adding their exponents together.
Okay, makes sense. Thank you.
Let's go to A times the A times the A would be 1 + 1 + 1, which gave us a A2R third there, okay?
Thank you. Makes sense. Thanks.
Oh, no problem. All right, y'all, so let me show y'all a little, what I call like a application problem doing that. So somebody's given us this formula, F of C. So the C is the variable for this one, equals 9/5 C plus 32. So notice the function lets you know that the C is the variable because that's what's in the parentheses. Anyone know what this formula is for?
Yeah, that's for Celsius temperature.
You got it right, but it's to find the so finding the Fahrenheit if we know the Celsius.
Oh, my bad.
So good job. So find Fahrenheit if we know the Celsius temperature. All right, so what they want to know, what Fahrenheit temperature is equivalent to -15 Celsius. So they're giving me a Celsius temperature, -15 degrees. So really, to find my Fahrenheit, I need to take the Celsius temperature that gave me -15. And that's what I'm going to be putting in from my function for the C in this formula right here. So we're going to bring down that 9/5. C is going to be a -15. And then we add 32 for that. Y'all, you're adding 32 and stuff because in Celsius, water freezes at 0 Celsius. In Fahrenheit, water freezes at 32. So that's how they're sort of getting the formulas and stuff. All right. Now we get to multiply and then add 32. But y'all, this one's not bad. Have y'all ever done tricks? What can you do with that -15 and that 5? Y'all remember that stuff where you cancel?
Yeah, cross cancel, that'd be
Uh-huh.
times 3.
So that'd be a -3 sitting there, okay? Good job. So
Can
9.
you break it down more since 9 and -3 are both factors of 3?
If the 3 was on the bottom still, Patrick.
Oh, okay. Okay. Thank you.
But basically, when you did the 15 and the 5, you turned the 3 on the -3 on top and a 1 basically on the bottom now. So now what you would do instead of wanting to divide, now multiply that top. That 9 times that -3. What's that?
-27.
Okay, so you got me a -27 plus my 32 at the end. So now y'all got to do a little unlike sign adding.
So it's just 5, right?
So 5. So that would basically be what? 5 degrees Fahrenheit now.
That sounds legit.
And so that's what we want y'all to see, that this function notation basically just gives me the number that I'm putting into my equations, and then I'm really just evaluating it. We don't do nothing with that F of 15. That's just symbolism to let me know what we threw in there, okay? All right, y'all. So then it has you doing a few graphs like we did in section 2.1. So I sort of showed y'all the tricks on those. So what I'm going to do is get toward the end of this lesson now, and we're going to look at what we call the vertical line test. Y'all probably use this sometime in your life. But here's the thing. A vertical line test tells me whether something is a function or not. So whether it's a function or not. To be a function, a vertical line, remember that's up and down like your y-axis. So to be a function, a vertical line cannot intersect a graph more than once. Okay, y'all, so I'm going to have me a graph. I'm going to draw a graph for you. And we're going to see if these are functions or not, going by what this is telling me. Now, remember, that vertical line, I'm going to run it left to right on my graph. It cannot touch the graph more than one point to be a function. So here's my first little graph. What if I had a parabola up here? Is a parabola a function?
Yes. No.
Well, let me ask y'all this. Here's our vertical line we're going to. The vertical line's only touching it once here. If you go around the graph, it's only touching it once here. If you come around the bottom here, it's only intersecting it once everywhere I go, right? Y'all see how that vertical line? Think about it this way. How many times does that vertical line intersect my graph?
Once.
How many times does that vertical line intersect my graph?
Okay.
Do y'all see that? No matter where I go, it's only going to hit it once, ain't it?
Yes.
No matter where I draw my vertical lines. So since these vertical lines are not intersecting it more than one time, this would be a function. And it sort of goes back to that choice. If a vertical line hits the graph more than once, that means the X value had two different Y values, right? And we said earlier when we was doing the charts that they couldn't. Y'all got the hang of it now? So let's see, what about this one? I got one shooting out like that. Looks like that absolute value. Is this one a function? Yes or no?
Yes.
Yes.
Okay, because now watch this. You're shooting your little vertical lines down through there. I think you're right. I don't see it hitting it but once everywhere, right?
Right.
So since them vertical lines only intersect this thing once, you're going to say, yes, like you said, good job. All right, y'all, here we go. X and Y. Sometimes you have graphs that sort of go to the side like this. Function, yes or no?
No.
Yes.
Good
No.
job. Yeah, good job. Because look, these vertical lines, they're hitting it up here and down here, hitting it up here and down here. So since the vertical line is hitting that thing more than once, it's definitely a no. One must be watching news. I hear some sirens on y'all. What about our friend the circle?
No.
No.
No, because he's violating everywhere, y'all. He's got vertical lines hitting everything. So function on that one was definitely a no. All right, so I'll try one more to mess with y'all, and then that's about it for our notes. Like I said, there's a little more graphing in this section, but they give you charts where they pick the numbers for you. So just plug their numbers in, get your points. It's doing the same thing we did in 2.1. And I sent y'all some videos last night for extra help, where I pretty much go through all those homework problems, okay? So y'all seen graphs that do this squiggly stuff. Is that graph I just did a function? Yes or no?
Yes.
Yes.
Oh, good job, because I can shoot them verticals. No matter where I go on that, it's going to intersect it just one time. So good job. That's a definite yes. All right, so I don't want to get y'all burnt out on my math class this first night. So if there's anything that bugs you, what I'm going to do different this semester, the main thing, we won't do a support lab tonight, because the main thing y'all got to do first off in this class is get into the Blackboard, go to the assignments, and do that course agreement. Okay, that's how you open up all your assignments, because it's like a prereq. So I want y'all to make sure to do that. We only got the one class this week tonight. Starting Monday, I will do my lectures, and then I'm going to leave my computer Zoom running for the support lab, and we'll use this support lab to help anybody that's behind homework or needs any extra help, okay? Now, sometimes I'll have y'all do support lab if there's like a little lecture in it that I need y'all to do, okay? Like I said, for this weekend, due by Sunday night would be your 2.1 support and college algebra, and then your 2.2 support and college algebra, okay?
Okay, I have a question.
Yeah, I hear you.
I was having some technical difficulties, so I know I missed the first half of the class.
Hey, guess
And
what? I'm
yeah.
recording. We recording this for you.
Oh, okay, so I can go back and look at it.
Yeah, so what it does, it takes me about 30 minutes to an hour to get them uploaded into YouTube.
Uh-huh.
And then what I do is I'm going to email you a link tonight. After every lesson we do, I'm going to
Yes,
email y'all a link in your email that'll go right to that video.
Okay, thank you.
That way, if something does happen like that, Amber, you'll be able to get back up in there and
Okay, thank you so much. I was so nervous about that. I just
so
couldn't get it
what
together.
was wrong with it?
Well, first I couldn't get the Zoom to download and load up. And then once I did that, I couldn't get my speakers to work. And so I went in there and I tried to do that. And so when I I tried to minimize it, but instead of minimizing it, I hit the X and then it took Zoom all the way out. So I had to re-download it. It was just a mess.
Yeah. And being a math class, being scared of math sometimes, you know.
Oh yes, I'm not afraid of it, but I definitely